This lesson begins a section on looking at polynomials and how complex numbers may be used in polynomials. First of all, I've got written here the standard form of a polynomial. Now you ought to be familiar with these from other maths classes and down into the lower year levels, but you may not have seen it written like this before. So I've got a polynomial in z. Z is my variable. The reason I've used z is because we may be talking about complex numbers, and it's standard practice to use z as a variable for complex numbers. But in Maths B or other lower maths classes, you may have used x as your variable. So here we've got pz equals some number a times z to the power of n, plus another number z to a different power, a power one less, plus dot dot dot, plus another number here times by z to the power of 1, plus a number at the end. So this is what we call our constant term. So this is our constant term. All the a's, they're all called our coefficients. They're our coefficients. They're the numbers in front of our variable z. N is called the degree of the polynomial. The degree of the polynomial is the highest power. Naturally, it's a whole number. Okay, so we don't have fractional powers in polynomials, just whole powers. So n is what we call the degree excuse me, of the polynomial. So as an example, I might have here p of z equals 3z to the 4 plus 5z squared minus 6z plus 1. So in this case we've got a polynomial. Its degree is 4. The degree of this polynomial is 4. The 3, the 5, the negative 6, they're called our coefficients, and the 1 is called our constant term. The reason it's called a constant term, naturally it doesn't have a z, doesn't have the variable z with it. Okay, now this particular polynomial, we say this polynomial is over R. R means real numbers. That means everything you see written here is a real number. So in other words, all the coefficients are real. Compare that with this polynomial. It might be 3 z to the 6 minus 4z to the 5 plus 3i z squared plus 10. Now notice a polynomial doesn't have to have, it can have terms that are missing. It's basically what that means is that the coefficients of those terms are 0. In other words, there's no power of 3, there's no z cubed, there's no z to the 4 in this polynomial or z term. That's because their coefficients are 0. But what I wanted to show you here is this polynomial has complex coefficients. Even though it's only got one complex coefficient, none of these ones are, but because this one has it has at least one complex coefficient, we say it is over C. Over C means it has a complex coefficient. That's a really important point later on when we get to some of the rules to do with factorizing polynomials. Alright, I'm going to keep going on this direction for a moment, and then in the next video I'll do some go back and do some more simple examples and build up your knowledge base behind what we're about to do. What I want to show you here is what we call the fundamental theorem of algebra. The fundamental theorem of algebra, it says if p of x, that's a polynomial in x, and now I've used x here because it doesn't necessarily have to be complex, But if p of x has x minus a as a factor, and remember what a factor is. A factor, what are the factors of 12? 12 is equal to 3 times 4. So 3 and 4 are both factors of 12. So if a polynomial has x minus a as a factor, then p of x may be written as x minus a multiplied by something. Now that something might be another polynomial. But because x minus a is a factor, p of x must be equal to x minus a times something. That's what factors are. 3 is a factor of 12. That's because 12 can be written as 3 times something else. Okay, so this is an important point to get to understand. If x minus a is a factor of p of x, then p of x can be written as x minus a times something, and that something could be some other polynomial, and I've just called it q. Now, following on from this, we have what we call the factor theorem. This is very useful. The Factors Theorem says if p of a equals 0, then x minus a is a factor of px. Sorry, I went to z. Doesn't matter whether I used x or z here as my variable. If p of a equals 0, then x minus a is a factor of my polynomial. Conversely, if x minus a is a factor, then p of a must be equal to 0. Now, have a look up here. To help you understand what this is saying, have a look up here. If my polynomial can be written as x minus a multiplied is a factor multiplied by something else, if I work out what p of a is, p of a means sub a in place of your variable. So p of a in this case would be equal to a minus a multiplied by q of a. Now, who cares what q of a is? If I've got a, take away a here, obviously that's 0 multiplied by something is still going to give me 0. So you can clearly see that if x minus a is a factor, in other words, it can be written like this: if x minus a is a factor, then p of a must be equal to 0, because I'll end up with a minus a as one of my factors, which is going to give me 0. So summarizing, if p of a equals 0, then x minus a is a factor, or just swapping that around the other way, if x minus a is a factor, then p of a must be equal to 0. Now, in the next video, I'm going to give you some simple examples of these that you probably will already be familiar with, and then we'll build up to doing some more difficult examples.